How to conduct a chi-square test in spss. Conducting a chi-square test in spss involves analyzing the association between two categorical variables. Here is a detailed step scenario. In this example, we'll use a hypothetical data set where we want to analyze the association between job satisfaction categorized as satisfied, neutral or dissatisfied, and stress level low, moderate or high among employees. Open your data file, launch spss and open the dataset that contains your survey responses with the variables job satisfaction and stress level. Set up cross-tab analysis. Go to Analyze menu at the top. Select Descriptive Statistics from the drop-down menu. Choose cross-tabs from the sub-menu. Define rows and columns. In the cross-tabs dialog box, move the variable job satisfaction to the rows box on the left by clicking on it and then clicking the right arrow button. This will define the rows of your contingency table. Move the variable stress level to the columns box on the right by clicking on it and then clicking the right arrow button. This will define the columns of your contingency table. Then options. Click the statistics button in the cross tabs dialog box. In the statistics dialog box, select chi-square under the chi-square category. This option will calculate the chi-square statistic. Optionally, you can choose to continue expected counts if you want to see the expected frequencies in the output. Click continue to return to the crosstabs dialog box. Click the cells button in the crosstab dialog box. In the cells dialog box, check the expected and percent options under counts if you want to include the statistics in your output. Then click continue to return to the crosstabs dialog box. Then format. Click the format button in the crosstabs dialog box. In the format dialog box, you can specify how you want the output table to be formatted, such as choosing the number of decimal places for percentages. Click continue to return to the crosstabs dialog box. Then run the analysis. Click an OK button, crosstab dialog box to perform the chi-square test. Then interpret the results. If spss will generate output that includes cross-tabulation table, chi-square statistics, p-values and other relevant statistics. Look for the chi-square statistic in the chi-square tests table and associated p-value. If the p-value is less than your chosen significant level, you reject the null hypothesis, indicating a significant association between the two variables. Then report the findings. Report the results of your chi-square test, including the chi-square statistic, degree of freedom and p-value. That's a detailed step-by-step guide. Remember to interpret the result correctly and make conclusions based on the statistical significance of the association. And Pearson's coefficient, which is a statistic used to measure the strength and direction of linear relationship between two continuous variables. Pearson's coefficient correlation, denoted as R, can range from -1 to 1. If R is close to 1, it indicates a strong positive linear relationship, meaning that as one variable increase, the other tend to increase as well. If R is close to -1, it indicate a strong negative linear relationship, meaning that as one variable increase, the other tend to decrease. If R is close to 0, it suggests a weak or no linear relationship between the variables. Pearson's correlation coefficient is commonly used in statistics to analyze relationships between variables, assess the strength and direction of associations, and make predictions based on linear patterns in the data. It's a fundamental tool in data analysis and is often used in fields such as psychology, economics, and the natural sciences to explore connections between variables. Which test leads to this coefficient? T-test or ANOVA or chi-square? Which one? So the coefficient you are referring to, Pearson's coefficient, is associated with correlation analysis, not the t-test, ANOVA or the chi-square test. Correlation analysis is used to measure the strength and direction of a linear relationship between two continuous variables. Pearson's correlation coefficient is specifically used in correlation analysis to quantify the degree to which two continuous variables are linearly related. It assesses how well a straight line can describe the relationship between these variables. The t-test is used to compare the means of two groups and determine if they are significantly different. It is typically applied when you want to compare the means of a single variable across two groups. ANOVA, analysis of variance, is used to compare the means of three or more groups to determine if there are significant differences among them. It is commonly used when you have one continuous dependent variable and one or more categorical independent variables. The chi-square test is used to assess the association between two categorical variables, typically in the form of a contingency table. It helps determine if there is a significant relationship between the two variables. In summary, if you are interested in understanding the strength and direction of a linear relationship between two continuous variables, you would use Pearson's correlation coefficient and correlation analysis. If you are comparing means across groups or assessing association between categorical variables, you would use t-test, ANOVA, or chi-square tests depending on the nature of your data and research questions. Why we conduct these tests? A t-test is a statistical test used to determine if there is a significant difference between the means of two groups. It is commonly used when you have a continuous dependent variable and a categorical dependent variable with two levels. The t-test assesses whether the observed differences in means are likely due to a real effect or if they could have occurred by chance. The t-test assesses whether the observed differences in means are likely due to a real factor or if they could have occurred by chance. Medical research example, drug efficiency. Imagine you are testing the effectiveness of a new drug in treating a specific medical condition. You have two options, one receiving the new drug and the other receiving a placebo. You can use a t-test to determine if there is a statistically significant difference in symptom improvement between the two groups. Education, people, test score comparison. Suppose you are investigating whether a new teaching method improves student performance in mathematics. You have two groups, one taught using traditional method and the other using the new method. A t-test can help determine if there is a significant difference in the mean test scores between the two groups. Marketing example, ad campaign effectiveness. In a marketing study, you want to assess whether a new advertising campaign leads to a significant increase in sales compared to the old campaign. You can use a t-test to compare the sales figure before and after the introduction of the new campaign. Then quality control example, product manufacturing. In a manufacturing context, you may want to know if a change in the production process results in a significant difference in product quality. You can use a t-test to compare the mean quality scores of products produced before and after the process change. Social science example, gender differences. In social science research, you want to explore whether there are gender differences in a psychological trait such as self-esteem. A t-test can help determine if there is a significant difference in mean self-esteem scores between males and females. In each of these examples, a t-test is used to assess whether there is evidence of a statistically significant difference in means between two groups. It helps researchers make informed decisions based on the data they collect and determine whether the observed differences are likely to be meaningful or simply due to chance. T-test example related to stress levels. Imagine you are conducting a study to examine whether a stress management program has a significant impact on reducing stress levels in participants. You have two groups, Group A, which receives the stress management program, and Group B, which does not receive any intervention. Your goal is to determine if there is a statistically significant difference in stress levels between the two groups after the program. Data collection. You recruit 50 participants, randomly assigning 25 to Group A and 25 to Group B. You measure the stress level of all participants using a standardized stress assessment tool before the study begins. Group A participates in the stress management program for 8 weeks, while B continues with their usual routine during this time. After the 8th-week period, you measure the stress level of all participants again using the same stress assessment tool. Your hypothesis for the study would be null hypothesis. There is no significant difference in mean stress levels between Group A intervention and Group B control over after the program. Alternative hypothesis, there is a significant difference in mean stress level between Group A and Group B after the program. To conduct a two-sample independent t-test to compare the mean stress levels between group A and group B after the intervention. After collecting the pre-test and post-test stress levels for both the groups, you calculate the means and standard deviations for each group. You perform the independent t-test which calculates the t-statistic and its associated p-value. Interpretation of results. If the p-value from the t-test is less than your chosen significance level, you reject the null hypothesis. Indicates that there is a statistically significance difference in mean stress levels between the hyper-intervention and control groups after the program. Based on the results, if you find that the p-value is less than 0.05, you can conclude that the stress managed program had a significant impact on reducing stress levels in participants compared to the control group. We can report these findings and consider the program's effectiveness in reducing stress level, which could have implications for future stress management interventions. Two sample independent t-test. How to conduct t-test in SPSS? In this example, we will use a hypothetical data set where we want to compare the mean test scores of two groups of students, Group A and Group B. Open your data file, launch SPSS and open the database that contains your test scores for Group A and Group B. Select independent samples t-test. Go to Analyze menu at the top. Select Compare Means from the drop-down menu. Choose Independent Samples t-test from the submenu. Define your variables in the Independent Sample t-test dialog box. Select the variable that represents your dependent variable test scores and move it to the test variable box on the left by clicking on it and then clicking the right arrow button. In the grouping variable section, select the variable that represents your independent variable group membership with values from Group A and Group B and move it to the grouping variable box on the right by clicking on it and then clicking the right arrow button. And click the options button and the interdependent sample t-test dialog box. In the options dialog box, you can choose to include statistics such as means, standard deviations and confidence intervals for each group by checking the corresponding options. Then check continue to return to the independent samples test box dialog box. Define hypothesis. You should have already formulated your null hypothesis and alternative hypothesis based on your research question. SPSS does not require you to input hypothesis, but you should have them in mind. And perform the t-test. Click OK. Independent sample t-test dialog box to perform the t-test. Interpret the results. T-test statistic and associated p-value. Examine the t-test table in the output. Look for two-tailed value in the Lewin's test for equality of variances row. If this p-value is greater than your chosen significance level, you can assume equal variances. Focus on the t-value in the t-test for equality of means row and the associated two-tailed value. Report the findings. Report the results of your t-test, including the t-statistic, degrees of freedom, and p-value. That's a detailed step-by-step guide. Remember to interpret the results correctly. Then how to get histogram and bar diagram. Charts are used for visualizing data in SPSS. Creating a histogram is used to visualize the distribution of a single continuous variable. For this example, let's say you want to create a histogram for a variable called scores. Open your data file, launch SPSS and open the dataset that contains your scores variable. Access the chart builder, go to graphs menu at the top. Select chart builder from the drop down menu, choose histogram. In the chart builder dialog box on the left side, you will see different types of charts. Select histogram under the gallery of charts. Drag and drop histogram into the main chart area. On the right, define the variable in the elements area on the right. In the variables box, select and drag the variable scores into the x-axis box. Customize the histogram. You can customize the appearance of the histogram by clicking on the element properties button on the chart builder dialog box. Adjust settings like number of bins, axis labels, and other visual aspects of the histogram. Create a histogram. Click OK. Creating bar charts is used to visualize categorical data or the distribution of a single categorical variable. Distribution of a categorical variable called categories. Open your data file, launch SPSS, and open the database that contains your categories variable. Access the chart builder, go to graphs menu at the top, select chart builder from the drop down menu, choose bar chart in the chart builder dialog box. On the left side, you will see different types of charts. Select bar under the gallery of charts. Drag and drop sample bar into the main chart area on the right. Define the variables in the elements area on the right. Select and drag the variable categories into the category access box. You can drag another variable into the values box if you want to create a grouped bar chart. Customize the bar chart. You can customize the appearance of the bar chart by clicking on the element properties button in the chart builder dialog box. Here you can adjust settings like axis labels, grouping options and other visual aspects of the bar chart. Create bar chart. OK button. Generate the bar chart. And we choose that we need to check some other aspects, like tomorrow we will be learning how do we know which graphical depiction will be best for a set of data in SPSS. Thank you.